Hi friends, let's have a look at problem 1813, Sentence Similarity 3. As you can tell from the title, so there are 3 such problems, so we're going to do them in the reverse order. So in this video, we're going to focus on problem 3. So we are given 2 strings, each representing a sentence composed of words. And a sentence is a list of words that are separated by a single space with no leading or trailing spaces, right? So here, 2 sentences, S1 and S2, are considered similar if it's possible to insert an arbitrary sentence inside one of these sentences such that the 2 sentences become equal, right? So it means that we can insert something to one of the sentence to make them equal. So in general, we should insert into the shorter sentence, right? So here it gives 2 examples. One is like, hello Jane, hello, my name is Jane. So this is indeed similar, right? You can insert this one. The second example here, because frogs and frogs are different. So no matter what you insert, so those 2 sentences cannot be equal. Therefore, they are not similar. So here you can also look at the examples. The first one, and the second one, so you can insert name is in sentence 2, right? So the return is true. So in the example 1, so here we have of. What is this of? It's in the middle of sentence 2, right? If you want to make sentence 1 and sentence 2 are the same, you need to add prefixes a lot to sentence 1 and also suffix words. So this makes the 2 sentences not similar. So in the third one, so eating. So here right now, so we just need to insert right now in sentence 2. So here actually is a suffix, right? So that's true. So here are some constraints that defines the problem size and the consistency of the problem. So as you can tell, because of the definition of similar, so we need to insert in between. So if 2 sentences are similar, then they should have, so if we delete the common prefix and the common suffix, then one of those should be empty, right? So this is the main observation. So let me comment it here. So we are going to identify a sentence as a list of words, right? And then 2 sentences are similar. Actually, it's equivalent to say after deleting common prefix and the common suffix. So the shorter one, the shorter sentence is empty, right? So you can see in the rigorous sense, we can think that one of the sentence should be empty, right? So it's possible both are empty because they are S1 and S2 can be identical, right? So now with this observation made, so actually this problem for the coding should be very straightforward. So you can first write one to mimic the process. So I'm going to write a solution to mimic the above observation. So this is for pedagogical purpose because this is the most straightforward thought. So first, let me do something like this: S1 and S2. So we're going to make it a list. So by splitting it, so S1 split. So the default separator will be empty space, so we don't need to specify here, and also S2 split, right? So this will give you the list, so you can print out just for some sanity check or have a visual understanding, right? So these are the 2 sentences. So now what we want to do is because we are going to delete common prefix and common suffix. So in order to save some time, we can make S1 and S2 a deque. So this way we can use the pop left method when we do deleting the common prefix. So rather than using for list, we are going to use pop 0, right? So this operation is expensive, right? So now how do we do this? This is also easy. So S1 and S2. So we are going to use the collections, this container deque, right? So this will make a deque out of S1. So you can call collections deque S2, right? So now we have our deque ready, right? So now let's mimic this procedure. So this will be very straightforward. Well, S1 and S2. So if they are not empty yet, so if the first word in S1 and the first word in S2 are the same, right? So we're going to do pop operations. So pop left, right? If you don't make S1 and S2 deques, so here what you need to write is S1 pop 0, right? So notice that for a list, if you pop the last element, it's O1 operation. But if you pop the first one, it's ON operation. That's why we use pop left after we translate S1 and S2 into deques, because this also constant time operation. So similarly, S2 pop left. So as I said for S1, so you pop 0 if you just use plain list. So that's the one. Otherwise, if they're not equal, right? For example, in this example, frog and frogs. So you just need to break. You cannot delete anymore. So this is for the prefix. We should do the same for the suffix. So we can do no, that's the So here we not consider the first element. We consider the tail element. But here we do not use pop left. We just use pop, right? So here we have no such considerations, right? So we're going to delete that, right? So after this deleting the prefix and the suffix, we should expect one of them is empty. So what we want to return is either S1 is empty or S2 is empty. We don't need to explicitly determine which one is empty or which one is shorter, right? So this actually is a full solution to this problem. So you can try to run that. It passes one example. Now let's look at this generic case. It passed all the cases. So here, one thing I want to mention is that you can work on index, right? You don't need to explicitly do this deletion. You can use two pointers to point to the beginning and end, right? Then you just see how many you can make them the same. So this actually, so I can write it as a practice. So write a solution using two pointers. Or pointers, not exactly two, right? Trick. So this way, actually here, like using two pointers, you can just stop here and then write the while loop. It's corresponding to improve the current solution from space ON to space O1, right? So with that said, I guess that's it for the current problem. You are welcome to follow up on the next, another two similar problems. In other words, sentence similarity 2 and sentence similarity 1. So that's it for the current problem and for the current video.